Hi and welcome to part 2 of the Unity Arkanoid tutorial. Let's have a quick recap of what we did last time. We built the 4 walls so the ball can bounce off them. We built the block, we built the paddle, and we built the ball. We gave things like the block sprite renderer so we could see them, and a box collider so we could hit them, and the paddle got a rigid body 2D so we can move it around, and the ball also got a rigid body 2D so we can move it around, and a circle collider rather than the box collider. So that pretty much covers what we did and how we set things up in the hierarchy. Now you might have found some problems. So when I go into my game view, I can't see the paddle. So let's have a look. Take a guess what you think it might be. I'll have a look at the paddle there. And if you look at the position, it's at -10. That should be 0 on the z-axis. Basically, it was in the same place as the camera, so the camera wasn't picking it up. Now, if we go back into our game view, we can see that the paddle's returned. You might also see that the walls don't actually quite reach the edge. Now, if we have a look at the left wall, can you spot the problem again? It's here. X should be 100. And that's the same for the other wall as well. Not entirely sure how that happened, but it should be 100. Let's just check everything else is looking good, looking good, looking good. Okay, so what we're going to do now, we're going to go into our assets folder and we're going to create a new folder and we're going to call it Prefabs. Prefabs are basically prefabricated game objects. So for example, let's do it. If we make a ball prefab, now we can drag more balls into the screen. We can do this in the editor. We can also do this by code using something called instantiate. So that's why we have prefabs. They're pre-made game objects for us to use in our game. So we've got the ball. Let's do the same with the paddle and the main camera and all of the walls together. Let's do. And the block on its own. So blocks is just really organizing, but I think those 4 walls are integral to the game, so I'm going to leave them in their own single game object. That works quite well for me. Okay, so we've made our prefabs. Now what we want to do is make this a bit more exciting, get a bit of movement, get a bit of player control in there. So let's click on the paddle, and if we go into our assets folder, create a new folder, call that folder scripts, open that up, right click, create C# script, and we're going to call this one player controller without the space. Okay, and we'll open that up in Visual Studio Code. And there we go. So we've got our player controller script, which inherits from the mono behavior. It's got some namespaces at the top, so we're using Unity Engine, and we're using something called System Collections and System Collections Generic. We've got a start method, which we don't need, so we're going to get rid of that. We've got an update, which we will need. An update is called once per frame, it's telling us that. First thing we want is a serialized field. And that's a float speed, and we're going to say 30f for now. We might tweak that a bit later. Serialized field basically means it's available in the editor for tweaking when you're playing the game and when you're in the editor. So in code it's set to 30f. In the editor we could change it to 50 if we want, or even when we're playing the game we can change it in the editor and speed up the movement of our controller. To move, we need a rigid body 2D. So let's get a reference to that. Rigid body 2D. RB2D. I'm hitting escape so it doesn't auto-complete that for me. And then we need to get to that rigid body 2D. And we want to do that in a function called awake. Now, it's auto-generating awake for me because I have these snippets as the extensions, Unity code snippets and Unity snippets. So that's what's providing that auto magically generated awake method for me. If you don't have these installed, if you're having problems with Visual Studio Code and Unity, check out my video for the installation of Unity and Visual Studio Code. Right, in our awake function, we're going to go RB2D equals get component, angle brackets, rigid body 2D, angle brackets, parenthesis, and there we go. Now in the update method, we want our RB2D again. And this time we're going to set the velocity, and we're going to equal a new vector 2, and that's going to be input dot get axis, and it's going to be called horizontal. We'll take a look at where that's coming from in a moment. So that's on the x-axis. On the y-axis, we're just going to do 0. Okay, let's save that up. So we'll go back into the Unity editor, and let's hit play, see what happens. Not a great deal, unfortunately. I must have made a mistake somewhere. Let's have a look. So our paddle doesn't have the script on it. Brilliant. Add component, player controller. Fantastic. Let's try again. And it's moving incredibly slowly. Let's go back and take a look at our script, see what's happening. The reason it's moving incredibly slowly is we forgot to times by our speed. Okay. And this time, yeah, there we go. We're zipping along now. Now, one of the problems you might have noticed is the ball is not moving around with the paddle. We want it to stick to the paddle at the start. So the easy way to do that is grab the ball and drag it onto the paddle to parent it. So now this ball is a child of the paddle. So let's play. Great. And we want a way to be able to shoot this ball off of the paddle. So let's just have a look at Edit, Project Settings, Input Manager. So this probably just says axes for you at the moment. Open that axis up. Horizontal. This is where we got our horizontal movement from. That's left and right cursor keys, or A and D. So that's what that was referring to. We're also going to use Fire 1, which is mouse 0 or left control. And we're also going to use Jump, which is the space button. Great. So we're on the ball. Let's open up the prefab. So we know the changes we're doing now are actually changes on the prefab. Just move me slightly up there and add component. And we're going to call this component ball. And we're going to, so let's do that again. Add component ball, new script, ball, create and add. And there's different ways of doing this. We can add component like that so we know that the script is on the ball now. But if we go into our assets folder, that script is not in the scripts folder. So there's lots of ways of doing it. None of them are perfect. You can create it in Visual Studio Code. You can create it in the editor. You can add it as a component to the game object. I'm just showing you a few different ways that you can do this. So let's open that ball script. Okay, pretty similar. We're going to have a serialized field. And this is how fast the ball moves. So we're going to need a float called speed. And this is going to be 15F, which is about half as fast as our paddle. So we should be able to chase the ball around quite easily. We want a rigid body 2D, RB2D again. And we need our awake function. Do you know how to do this yet? Have a go while I'm just moving my cursor around. You can pause the video if you like. And it's RB2D equals get component angle brackets rigid body 2D close angle brackets parenthesis, and there we go. Our update method, we don't need an update method at the moment, so we'll get rid of that. What we do want is a public void, and we're going to call that launch, so we can launch this ball. Public means it can be accessed from other classes. Void means it returns nothing. Launch is the word we've chosen to call this method. We want to pass in a vector 2, and we're going to call that direction. Okay, so here we go, we're launching the ball. What do we need to do? The first thing we need to do is say transform.parent equals null. So that will detach it from the paddle. So that's the first step. And after that we want to I said I was going to forget this in the last video. I'm not going to forget it. rb2d.simulated equals true. If we don't do that, then nothing will happen to the ball because it's not in the physics system being simulated. The reason why we have this simulated is it's much more cost efficient to turn simulated off true and false than, for example, removing the component and adding the component back. When you do that, it has to recalculate the whole physics system, which is a big hit on the resources. So that's why we're using simulated equals true, simulated equals false to turn the physics on the ball on and off. And then we want to launch, so we need to get our rigid body, and this time we're going to set the velocity, and we're going to select it to a new vector 2. I say with that we're going to set it to direction dot normalized, and we're going to times that by speed. So it's taking the direction that's got passed in. That direction could have any magnitude. It could be, traveling super fast in 45 degrees. But we're going to normalize that to the unit vector, and then we're going to times it by the speed, so we get our 15f speed every time we launch, regardless of what we put in that direction. Cool. We're not going to use this, but I want another public void, and I'm going to call this one catch. And it's going to take a transform called parent. So what we're going to say is transform dot parent equals parent. RB2D dot simulated equals false, so we take it out of the physics system so it doesn't bounce straight off the paddle. And RB2D dot velocity equals vector2 dot 0. In my previous video on Pong, I used sort of new vector 0, 0 on the x and y axis. That was just to give you an idea of how vectors worked. If you haven't checked out the Pong tutorial, check it out. But we're going to use the nice and simple vector2.0, which is 0 in the x, 0 in the y, all set up for us already, which is great. So we've got our launch, we've got our catch, we've got our awake. That's looking pretty good. So we're going to save that. Going to zoom back over into our player controller. So basically what we want to do is, if we have a ball attached to us, so let me just have a quick think about how we do this. It's the transform child count greater than 0. So if we've got a child and input dot get button down. We're going to use jump for this. And what are we going to do? You're going to say ball equals get component in children ball, and ball dot launch, and we need to put in a direction there. So for now we're going to have a serialized field, and it's going to be a vector2. It's going to be launch direction, and we're going to say equals new vector2. We're going to go 1 in the x and 4 in the y, just arbitrarily, really. Okay, we'll save that up. And we'll switch over to the editor. Save our prefab. Save. And save our scene while we're here. Hit play. We can move left to right, the ball's following us. When we hit the space bar, we're launching, and then we're stuck against the wall. And then we're dropping down very slowly. So we had a bit of a problem there. If we look at the ball, we haven't put a physics material on it, so we need to create a new physics material. Create folder, call it physics material. Create physics material 2D, and we're going to call this bouncy. Friction is 0, bounciness is 1. Then we'll open the ball prefab this time and drag in this bouncy physics material onto it. Save it. Go back and play. Okay, we're bouncing. And we're bouncing off the blocks. What happens when we hit the floor? We bounce. Okay, so we've got a game. It's playable. A little bit boring, but playable. Cool. So we'll finish there, and looking forward to part 3, where we'll look at damaging blocks and destroying blocks. We'll also take a look at a custom bounce with our paddle, so it bounces off at different angles based on where the ball hits. If you've done the Pong tutorial, it's pretty much exactly the same thing, but on the horizontal rather than on the vertical. So that'll be interesting. And also we'll make this bottom wall the wall of death, which will destroy any balls that hit it. So then we'll have sort of more of a game going on. Cool. See you in the next video.